All right, so we are going to start talking about the 5 types of reactions. So far you should be comfortable converting names into formulas and writing and balancing reactions. Well, now we're going to start talking about, well, how do we predict what the products are going to be? So when we do reactions, we put 2 things in and we get, or 1 thing in, and we get something out of it. We're going to go through this chapter and figure out, well, how can we determine before we even perform the experiment what we're going to get out of it? So what are the products that are going to be made? So to do this, we're going to talk about the 5 different arrangements of reactions that we have. So the first one we have is called composition, or also known as synthesis. We will reference it more as a synthesis reaction. Okay, and a synthesis are when you have 2 or more substances combined and they form a new, more complex compound. So a way to recognize this is by looking at the product side. So if you start with many things on the reactant side and end up with way less on the product side, that is a synthesis reaction. So for example, it's taking A, so our generic formula is A plus B, and that'll give you AB. So we'll notice here we have one thing added to another. So we have 2 things on the left side, and on the right side we only have 1 product made. So your synthesis, you should see 1 product made or less. So here we started off with 2 reactants and we ended up with only 1 product. So we started off with more things and they came together to form one larger, more complex substance. An example of this reaction, so we're going to do some examples in a lab tomorrow. We have, or later this week, so we're going to have iron plus sulfur, and that'll give you iron 2 sulfide. So we have element plus element, and it is going to give us one more complex compound. So that is our synthesis reaction. We're synthesizing multiple things together. So 2 simple things to form one more complex thing. Then we have what is called decomposition. So think of when something decomposes. Okay, when something decomposes, it breaks down. So when an animal decomposes, it breaks down into gases. So decomposing is when you take one complex thing and you break it into simpler things. So for example here, we have AB, so one compound is going to break into 2 smaller things. So a way to recognize this is if you have less reactants than products. So if you look at your reactants and they're breaking up into your products, that's called decomposition. So an example is copper 2 carbonate. That is going to decompose or break apart into copper and carbon dioxide. So it's starting with one complex thing, so one complex reactant, and it's breaking into 2 smaller products or 2 simpler products. A lot of times decomposition reactions, we need to add what is called a catalyst. Okay, and a catalyst is something that's going to speed up the reaction. So a lot of times catalysts will be a chemical. Okay, it'll be heat, so different things that are going to speed up the reaction, because otherwise the reactions will just take a really long time before you see something. So a catalyst will just speed this up so it happens instantaneously or at a lot quicker of a rate. So then we have what is called a single replacement. So the third one is single replacement. So this is when one single thing is replacing another one. So this is where you're going to have a compound plus an element. So you have compound plus element, and it's going to create a new compound and a new element. So if you look here, we start with the compound AB, and we start with the element. So we have compound and an element, and we're going to create a new compound and a new element. So we're doing one single replacement. So C is replacing A in this reaction. So for example, here we have element plus a compound. So we know we're doing single replacement. So the copper is replacing, so we look at our copper, our copper is replacing our silver. So it's kicking that silver out. So now silver is by itself and copper replaces itself in the compound. So one atom or one element replaces itself into the compound. In our generic formula, make sure you write that down, AB plus C equals A plus BC. The fourth one we have is what is called a double replacement. So this means two things are being replaced. So here we have AB plus CD and is going to create, so A is going to replace C and B is going to replace D, and it's going to create AD and CB. So we create, so it's compound plus compound, and it gives us compound plus compound. So an example of this is potassium iodide, which is Ki. So we have our compound potassium iodide, so Ki, and lead nitrate, which that should say lead 2 nitrate, and that's going to create lead iodide and potassium nitrate. So we have compound plus compound. So again, we have Ki plus PbNO3 2, so lead 2 nitrate, and that gives us lead iodide, and then we're going to get potassium nitrate. So it's compound plus compound gives us compound. So we're going to get compound plus compound. So you should see we start with potassium iodide, lead 2 nitrate, so compound, and we get 2 new compounds. So that's double replacement. And then we would, of course, balance this. Let me just balance it. So we'd go through and add our coefficients. Pen's not working, so we're just going to let you guys balance it. And then the last one we have is combustion, and there's technically two types of combustions. So there's a combustion of a hydrocarbon, and then there's a combustion of a metal. So a combustion of a metal is a metal reacting with oxygen. Combustion of a hydrocarbon is a hydrocarbon reacting with an oxygen. So anytime you see something reacting with oxygen, that represents a combustion reaction. Okay, and that overplaces any other types of reactions. So again, combustion is anything that is reacting and combining with oxygen. A metal, for example, down here, so magnesium reacting with oxygen will give us magnesium oxide. Okay, this clue right here is that we have a combustion reaction. A hydrocarbon, so these ends mean that they can be any number. So we can have, for example, C2H8. Okay, they can be C3H10. It doesn't matter the arrangement of the carbons and the hydrogens, or the numbers of the carbons or the hydrogens. As long as it's a hydrocarbon, meaning it's made out of hydrogen, that's why so it has to be a hydrocarbon. And a hydrocarbon is anything made out of hydrogen and carbon. That's why it's called hydrocarbon. Anytime you react one of those with oxygen, it automatically makes carbon dioxide and water. You don't have to do any other work, just carbon dioxide and water. So for example, here we have methane, CH4, reacting with oxygen, creates carbon dioxide and water. This magnesium oxide, so our magnesium metal, you do the same thing as a synthesis reaction to predict your products. So these are the different arrangements of reactions. We're going to go through them step by step, and we're going to go through how we can actually predict the products, but this is just kind of an introduction so you can kind of see how we make our products, or what our products are going to kind of look like based on the reactants that we're given. Whenever we make compounds, we crisscross. Okay, so if we look here, we're putting magnesium and oxygen together. So Mg is plus 2, oxygen's minus 2. So that's how we get magnesium oxide, is by making sure that we have 1 Mg for every 1 oxygen. So again, we're going to talk more about these in depth, but at least now you kind of have an introduction of what the types are.